All right, there we go. So unlike other scientists around the world who use this metric system, in America, we use where to go? Imperial System. And with that, we have the kind of funky units, right? So we have 12 inches go into a foot, and then 30 feet go into a yard. 36 feet. No, duh. Even I get confused. 12 inches in a foot, 3 feet in a yard, 1,000 something yards are in a mile. There's also 5,280 feet in a mile. And then you have pounds, and a pound is made up of 16 ounces. And then the ounces can go down to like half ounces or quarter ounces. And then you also have fluid ounces, which is something different. It's all very confusing, and it doesn't really fit together all that well. So instead, in science, we use something called the metric system, which not only is used more frequently by scientists around the world, but also it has a much simpler way of converting between the smaller units to the bigger units, which we're going to talk about today. So the kind of three main ways, the three main measurements that scientists make about the world around them are length or distance, mass or weight, and volume, how much space that something takes up. So the first type of measurement that we're going to be talking about today is length or distance. And so instead of our normal English units, which would be things like miles or yards or inches, in the metric system, instead we use units based around meters. So there are meters, there are kilometers, which are bigger, there are centimeters, which are smaller, and we'll talk about those guys a little bit more in just a second. So when you compare the metric system to the English system, you get some interesting comparisons. So 1 mile is approximately 1.5 kilometers. So like I think a 5-kilometer race is something like 3 or 3.1 miles. 1 inch, so up here on this little ruler, we have inches on the top, that's from the 0 to the 1, and then centimeters along the bottom. So 1 inch is approximately 2.5 centimeters, a little bit over 2.5 centimeters. A meter and a yard are pretty close together. They're almost the same. So if you've ever seen a yardstick in like a classroom, a meter stick is pretty close to that same length. So the base unit, what we call the base unit for measuring length in the metric system, is the meter. So you may have noticed that when we were talking about things, we had the centimeter and the regular meter and the kilometer. They're all based on the meter. That's what's called our base unit. So if we go bigger than meters, we can have kilometers. And kilometers are 1,000 meters. You take 1,000 of those meter sticks, you stick them end on end on end, and you'll get 1 kilometer. 1 meter can also be broken up into smaller pieces. So a meter is made up of either 100 centimeters. So this meter stick right here goes all the way from 0 to 100 centimeters at the end. Or if we wanted to break it down into smaller units, a meter can also be classified as 1,000 millimeters. So a millimeter is even smaller than a centimeter. So there are 1,000 of them in 1 meter. So this is kind of what I was talking about before, with how the metric system makes a lot more sense in terms of going from bigger to smaller. Instead of going from 12 inches is a foot and 3 feet is a yard and 1,300 yards is a mile, it's all based on factors of tens or hundreds or thousands. So a kilometer, 1,000 meters. A meter, 1,000 millimeters. 100 centimeters makes up a meter. So based on this, we could also figure out that if 100 centimeters and 1,000 millimeters both make up the same distance, that means that there must be 10 millimeters for every 1 centimeter. So 10 millimeters make up each centimeter. Then there are 100 centimeters that make up a meter and 1,000 meters that make up a kilometer. All very simple to go through based on tens, hundreds, or thousands. So that is our units of length. So again, here we have kind of a rough approximation of some centimeters and millimeters up here. So if you have 1 centimeter, then if we counted each one of these little lines in here, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 millimeters go into each centimeter. So, for example, if we were to measure the length of this blue line right here, if we were to count by centimeters, then we'd say this is, all right, let's see here. We have 1, we have 2, we have 2.5, 2.6, 2.7, 2.8. So this blue line is approximately 2.8 centimeters. We could also just as equally say that this blue line is in millimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 millimeters. So whether or not we measure it in centimeters or millimeters, it's the same set of numbers, right? It's either 2.8 centimeters or 28 millimeters. So again, very, very easy to transfer between those. Unlike if you've ever measured the kind of small things in terms of inches, like I had to do that recently for some things that I was putting on my house. I was putting the little handles on some of my drawers. And once you get down really small, then you're dealing with like 3/16 of an inch, and then you have 2 3/8 of an inch, and then you have 1 inch and 3/4, and it's all kind of a big mess. Here, if we go smaller, we just go down by tens. So we could say 2.8 for the centimeters, or just as equally 28 for the millimeters. So that is how scientists measure length or distance, is by using meters and the bigger or smaller sizes of meters. Anybody have any questions about our length measurements so far?
No, sir.
All right, thank you. So the other two things that we're going to talk about, hopefully you'll see that they have a similar pattern in terms of how their measurements work, as we saw when we were talking about measuring length. So up next, we're going to talk about mass, which is the scientific term for how much something weighs, essentially. So again, if we think about English American weights, we have pounds and ounces, right? Those are kind of the main ways that we measure how heavy that something is. If we went up to like really, really, really big, we could have things like tons, right? So there's 2,000 pounds in a ton. On the metric side, instead of using pounds and ounces and tons, we use grams. So a pound is about 450 grams. So a gram is really, really, really small. Like if you think about the weight of like a single quarter, that would weigh about a gram.
Hey, Mr. Stanley.
Yes.
I'm at work right now, so I'm only gonna be able to be on here for a little bit. There's a lot
That's
of
all
like
right,
rushing and
Gabriella.
stuff in the back.
All right. Thanks for dropping in and thanks for letting me know.
Okay, sounds
Just like
good.
with all the other note sets, I'm making sure to record this one so you can go back and look at it later if you need to.
Okay, sounds great. Thank you.
No problem. Thanks for being here. All right. So instead of dealing with ounces into pounds into tons and the metric system, instead we use things like grams and kilograms, where a gram is really, really small, and then a kilogram is about 2.2 pounds. So if you think about like a big, heavy textbook that maybe your kids have for one of their classes or that you had when you were going to high school back in the day, one of those big textbook weighs about a kilogram is kind of a general estimation for that. So our base unit is the gram. And if we put 1,000 grams together, we get a kilogram. So instead of meters and kilometers, we have grams and kilograms when we're talking about weight. Or if we split up a gram into 1,000 pieces, then we have milligrams. So you've probably heard of milligrams before when it comes to things like medicine. So like a little tablet of ibuprofen or acetaminophen will usually have about, depending on what type of medicine it is, maybe 100 milligrams of medicine in each tablet. So it's not saying that the tablet itself weighs 100 milligrams. The tablet is probably around 1 to 2 grams, but the actual amount of medicine inside that tablet is a little bit smaller amount. So grams is our base unit. And then if we put 1,000 grams together, we have a kilogram. Or if we split a gram up into 1,000 pieces, each one of those pieces would weigh 1 milligram. So that is our weight measurement. We don't use ounces and pounds and tons because, again, those guys, when it comes to converting between them, it's kind of hard to figure out, right? You have your ounce, and then 16 ounces make up a single pound. And then you need 2,000 pounds, and that's what makes up a ton. Grams and kilograms and milligrams is a lot simpler. 1,000 milligrams in a gram, 1,000 grams in a kilogram. Bing, bang, boom. All done. All right, so finally, after we have our weight, our final one that we're going to talk about is our volume. So volume is how much space that something takes up. A lot of times when we talk about volume, we're talking about liquid volumes. So we have things like fluid ounces. So like there's 12 fluid ounces in a normal can of soda, for example. We have things like liters, or quarts. So quart, if you get like a quart of milk, it's like the really kind of thin carton of milk. And then pretty commonly we have gallons. So like a gallon of milk or a gallon of water, everybody's familiar with that amount. In the metric system, instead of using fluid ounces and pints and quarts, instead we use what are called liters. So you might have seen liters before at the grocery store. A lot of times you can get like Coke or Dr. Pepper or Sprite in the big 1 or 2 liter bottles. And that's what it's referring to, is the size of those bottles. So a liter is really, really close to the English quart. So for example, a gallon is almost 4 liters. It's a little bit less than 4 liters makes up a gallon. So liters, we usually don't really go bigger than liters when we talk about metric units. Like scientists don't really use kiloliters a whole lot. But one that does get used a ton is milliliters. So just like how milligrams are, if we took a gram and chopped it up into 1,000 pieces, milliliters are the same thing for liters. They're the smaller version. So if we take 1 liter and we spread it out into 1,000 equal bits, that's what gives us 1 milliliter. So usually I like to think about, like, if you have like an eyedropper bottle, 1 drop out of that bottle is about the size of 1 milliliter. Or like a raindrop is approximately 1 milliliter. Another way that we can measure volume, measure size, instead of doing it in liquid volume, which is what liters and milliliters are for, if we want to do it for solid volume, we can use something called cubic centimeters. So if you ever see these like cm3 used for the measurement instead of like ml for milliliters or L for liters, that's referring to cubic centimeters. And it just means that if you have a tiny little like block that's 1 centimeter long on each side, that would be a single cubic centimeter. So if we had something, for example, that was 10, like a big block that was 10 centimeters tall by 10 centimeters wide by 10 centimeters deep, then we would say that it is 1,000 cubic centimeters, because those are the dimensions of this box that we had. So again, liters, milliliters, and cubic centimeters are what we like to use for our units in the metric system when it comes to volume. So for length, we had our meters, and we could have kilometers or centimeters or millimeters as our units. For weight, our base unit was the grams, and then we could have kilograms or milligrams to go bigger or smaller than that. And then in volume, our base unit is the liter. So that's kind of the original unit. And then when we go smaller, we can have milliliters, talking about solid mass. We can also phrase it as centimeters cubed. That's what the little 3 here refers to, as cubed. So length, mass, and volume, meter, gram, liter. All right. Anybody have any questions about our different types or units of measurements so far?
No, sir.
All right, thanks, Breeze. Okay. All right. So sounds like everybody has that down, feels pretty okay with that, which is good because that's kind of the warm up to sort of the main meat of our topic for this evening. And that is the idea of converting between different metric units. So if we want to, if we have something that's in meters and we want to know, well, how many centimeters is that? Or how many kilometers is that? The nice thing about the metric system is that it is fairly easy to do those conversions. And the easiest way that I've found to think about how to convert between one type of measurement and another is through something called the ladder method. And so the ladder method looks like this. It can also be called like the stair-step method. I've heard some people refer to as well. So here we have these little boxes that represent different steps on the ladder or different steps on the stairs of our different sizes of unit. So a couple things to notice right off the bat. We have our basic unit right here in the middle. So again, that's referring to meters, liters, or grams if we're talking about length, volume, or weight. Up here we have our kilo, whether that's kilometers, kiloliters, or kilograms. That's kind of our 1,000 unit. So remember, 1,000 meters makes a kilometer. 1,000 grams makes a kilogram. And then down here we have our centi for our centimeter. So again, 1 centimeter is a 100th of a normal meter. That's what the little 0.01 here represents. We have 100 centimeters make up a meter. We also have even further down our milli. So whether that's millimeters, milliliters, or milligrams, 1/1000th of a gram is a milligram. So 1/1000th of whatever our base unit is one of our milli units, our smaller movements. So to use the ladder method, there's 3 basic steps that you go through. So first off, you have to determine what is your starting point. So for example, if we said our starting point is 4 kilometers, and we wanted to know how many meters is in 4 kilometers. So we know 4 kilometers, we want to know how many meters. Kilometers are our starting point, and meters are our ending point. So 4 kilometers, so that's kilo for kilometers. So that's going to be up here. That's our starting point. And then our ending point is meters, our base unit. So if we start at kilometers and we want to go to meters, there are 2 different things that we have to keep track of when we're doing this conversion. The first is how many steps do we have to go through in order to go from one unit to the other? So how many steps do we go to go from one to the other? The second one is what direction are we going? Do we have to take steps to the right, or do we have to take steps to the left? So, for example, kilo is over here. That's our starting unit. Our ending point is meter, which is our basic unit. So we start here. To go from kilo to meter, we're going to move to the right. Okay, because kilo's up here, meters to our right. And we're going to take 1, 2, 3 steps in order to get here. So these red lines and numbers up here corresponds to this example. So when we start at kilo, we go 1, 2, 3 steps down, and now we are at our base unit. We are at our meter. So that whole process was the second step. Count the jumps from the starting point to your ending point. Starting point is kilo, ending point is basic meter. We had to go 1, 2, 3 jumps to the right. Then on our original number, what we're going to do is move our decimal point the same number of jumps in that same direction. So in this case, we started off with 4 was our original number. And then we said that to go from kilo to meter, we had to take 1, 2, 3 jumps to the right. So we're going to do that with our decimal point. Sorry that it kind of keeps getting covered up by the slide thing. But when we have our 4, so our 4 is right here. And then we're going to move that decimal spot 3 jumps to the right. So 1, 2, 3. After we do that, we fill in all of those open spaces with zeros. So when you move the decimal point and you don't have any number to go in that spot, you just put a 0 in there. So that's how we can figure out that 4 kilometers is the same as 4,000 meters. We saw we had to do 3 jumps to the right. So our decimal point was initially here for 4,000 or for 4 kilometers, excuse me. And then we moved that decimal point 1, 2, 3 jumps to the right. So now our decimal point is down here where my little red dot is. And we filled in those 3 open spaces with zeros. So we ended up with 4,000 meters. So figure out your starting and ending point, move your decimal, or figure out how many jumps to go from your starting to your ending, and then move your decimal that many spaces. So let's do a couple more examples. To kind of see some more of what I mean. So if we have 1,000 milligrams, and this is saying that that is equal to 1 gram. So let's see if that is correct. So our starting unit is milligram, which is going to be milli over here. And our ending unit is gram, which is one of our basic units right here. So if milli is our starting and basic is our ending, then if we start from milli, we have to go 1, 2, 3 jumps to the left, right? Milli is over here. Basic gram was to the left. So we did 1, 2, 3 jumps to the left. So that's what we did to go from milli to basic. So now if we do that with our decimal point, this one doesn't have one put in already, which means that it's just hanging out here, kind of invisible at the end of our number. So if we take that decimal point and move it 1, 2, 3 spots to the left and put it right here, that is going to give us 1.000 or 1 gram. So when we had 1,000, when we moved the decimal spot 3 jumps to the left, our new conversion was 1. So we started at milli, did 3 jumps to the left to get back to basic, and then did that same 3 jumps with our decimal point and figured out that 1,000 milligrams is equal to 1 gram. All right, so I'm going to do a couple more examples, but hopefully, instead of just kind of showing you by moving my cursor around, I'm going to do it on a whiteboard instead, so you can hopefully see it a little bit more clearly. let's see, there we go. There we go. And there we go. All right. So let me recreate our ladder really quick. So we have kilo up here, and then a couple ones that we don't really care about. And then our base is right here. And then we have centi right here. And milli right here. All right, not quite as pretty as the other one, but I think it'll work for our purposes. So one of the next examples was, it says that we have 160 centimeters, and I want to know what that is in millimeters. So 160 centimeters, but I want to know that measurement in millimeters. So first step, figure out our starting point and our ending point. So centimeters right here will be our starting point, and millimeters, its next door neighbor, is going to be our ending point. To go from centimeters to millimeters, we go one jump to the right. So we have one step to the right to go from centimeters to millimeters. So we do that the same with our centimeters number. So we started off with 160 centimeters. If we take our decimal point that's at the end there and move it one spot, and then fill in this empty space with a 0, we can see that 160 centimeters, when we move that decimal place one spot to the right, is going to be 1600 millimeters. So 160 centimeters is 1,600 millimeters. So we started at centimeters and had to take one jump to the right to make it to millimeters. So we took that decimal place in our centimeters, took it one jump to the right, and that gave us with an extra 0, giving us 1,600 millimeters from 160 centimeters. All right, so I'll do some more examples in just a second, but is there anybody who has any major question, or anybody who's still super confused about what is going on up to this point?
No, you explained things pretty well.
Okay, so everybody feels kind of okay with how we're moving our decimal place around so far?
Yes, sir.
All right. Let's see, what's another good example we can do? Okay, good. So, oops, hold on. What if instead of going to the right, we go the other way? So if we have 109 grams, well, I'm going to rewrite that to be a little bit more centered. All right. we've got 109 grams. And now I want to know how many kilograms is that. So grams is one of our base units. So that is going to be our new starting point. So grams for the base is our starting point. Kilograms, that's the guy that's way up here at the top of our ladder. That's our ending point. So we're starting with grams and we're going to kilograms. Well, in order to do that, we have to go 1, 2, 3 steps, and we're going 3 steps to the left, right? Started at grams, ended at kilograms, meant 1, 2, 3 steps to the left. So let's see what we get when we move our decimal place 3 steps to the left. We have 109 grams here, and so our decimal place is right here at the end of our number. And so we go to the left 1, 2, 3 spaces. Now our decimal point is in front of our digits. So instead of having 109 grams, we can say that that is equal to 0.109 kilograms. So if you want to do 0.109 or 0.109, both are the same thing. But 109 grams, when we move the decimal place back 3 spots, it gives us 0.109 kilograms. So we figured out our starting and ending spots. We counted the number of steps in a certain direction to go from the starting to ending spot. And then we do that same number of jumps in that same direction with our point. So we just move it the number of spaces that we figured out by counting on our ladder up here. So that's why it's really nice to be able to use these metric systems, because it gives us a way to very easily transfer in between one or the other one, right? If we were dealing with like pounds and ounces, then we would have had to be multiplying or dividing by 16, depending on which one we were going to. And it's just overall more confusing and not as nice and straightforward. All right, so I think I have one more kind of good example that I wanted to show you guys. So let's see. So all the ones that we've looked at up until now have been transferring starting from a number that is like a whole number, right? That doesn't have any decimal points. So when we have one of those numbers, like a 109, we say that the decimal point is at the very end of the number. Sometimes, though, we get a number where the decimal point has already been given to us. So, for example, we could have a case where we know that something is 5.6 meters long, and we want to know how many centimeters is that. So 5.6 meters that we are going to convert into centimeters. So get rid of all of these guys. All right. So meter is right here as one of our base units. So that's going to be our starting point for this equation. Centimeters are over here, a couple spaces down from our meters. So that's going to be our ending point. So if we start at meters and go to centimeters, here, let me ask you guys, how many steps do we have to go in order to go from meters to centimeters? How many steps is it going to be?
Two, right? If we're starting at base.
Exactly. 2 steps. So if we start out on our base, 2 steps is how many it took to get to our centimeters, which is our ending. And then which direction did we take those steps? Did we go step to the right or step to the left?
To the right.
To the right, exactly. So to go from meters to centimeters, we have to take 2 steps to the right. So if we have 5.6 meters, they're nice enough so that we know where our decimal point is. It's not at the end of the number in this case. It's right here in the middle. So if we take that decimal point and go 1, 2 steps to the right, so after we move that decimal point, then how many meters, or how many centimeters, excuse me, are in 55.6 meters? So what is our final answer here after we moved our decimal point 2 spots to the right?
56 centimeters.
Close, but not quite. If we just
Wait a minute.
if we
I got
just
the wrong
moved it
answer.
one
It's 'cause,
jump,
I'm dealing with something else right now. I was going to inform Mr. Stanley. I kind of have a big issue I got to go deal with. Is it cool if I leave class today kind of early?
yeah, that's fine, Fernando. Thanks for letting me know.
Oh, it's Jonathan.
Oh, sorry, Jonathan. I was looking at the wrong.
No worries. Yeah,
name.
somebody got it already. I got to take care of that right quick.
All right. Yeah, no worries.
Bye-bye.
So Jonathan was pretty close. If we had just moved it 1 spot to the right, then it would have been 56 centimeters. But we moved it 2 spots. So if we fill in that extra spot with a 0, then how many centimeters is equal to 5.6 meters?
58.
5.
Not 58.
56 is 560?
560. Bingo. That is correct. Remember, when we moved it that second time, we don't have a number there already, so we fill in that blank space with a 0. So 5.6 meters is equal to 560 centimeters. So that extra 0 comes from the second time when we moved that decimal place, right? Because we said that we had to take 2 jumps to the right. So if we just took 1 jump to the right, that's what would give us 56. But that second jump is what gives us 560.
I have a question. So the base is always at meters. Is that correct?
Yeah. So if you ever see meters, grams, which is a G, or liters, which is a capital L, those are our basic units. So if you have a M, if you have a G, if you have an L, those are all part of the base. And then you could also have kilometers or kilograms up here, or centimeters down here, or millimeters, milligrams, and milliliters down with our milli down here. So yes, meters, grams, and liters are our base unit. So if you're starting off or ending on one of these units, that means that you're either going to be using that as your starting point or using that as your ending point, your base right here. All right, good question. All right, here, let's do one or two more examples together just to make sure everybody's got this all down. So we're just gonna do like that. All right, let's see here. What would be a good one? Ooh, yeah, that's a good one. All right. If we have 104 kilometers, then how many meters is that going to be? I don't want to give too much away, but we're going to need some more space. All right, we're going from kilometers to meters. So kilometers are up here at our very top of our ladder. So that's going to be our starting point. And then meters, like we were just saying, is our base unit for length. So our base is going to be our ending point. All right, so first step completed, figured out our starting point, kilometers up here, and our ending point, meters, down here. Next step, how many jumps does it take to go from kilometers to meters? So if we're starting at kilometers up here, and we're going to meters, our base unit down here, how many jumps is that going to take us? How many steps on our ladder? Feel free to either share out loud or put it in the chat.
Would it be 4?
4, but you're close. We have kilometers right here. Then we have this step. Then we have this step. Then we have our base right here.
So it starts at kilometers. Is that right?
Yep. Mm-hmm.
So we would move it 3 to the right.
Hey, exactly. So we start at kilometers. We go 1, 2, 3 steps to the right. Exactly. So when we start at kilometers and we're going to meters, which is our base unit, we're going 1, 2, 3 steps to the right. So that's what we're going to have to do with our decimal down here. So 104 kilometers is one of those whole numbers. So the decimal starts at the very end of the number right there. So 3 jumps to the right means we go 1, 2, 3 jumps to the right. Remember, each one of these blank spaces is going to be filled in with a 0. So if we have 104 kilometers, what is that in meters?
Yeah, I don't know how to say that.
You can just tell me the numbers.
Like if I was like regular math problem, I would say it like that.
Sure.
That's 1,000, right? 104,000, or no?
Yeah, exactly.
Okay.
104,000. 1, 0, 4, 0, 0, 0. So 104 kilometers is 104,000 meters. If it helps, I can put a little comma right there to separate those two sets of 3. So we figured out our starting point is kilometers up top. Our ending point is meters down here at our base. We had to do 1, 2, 3 jumps to the right in order to go from kilometers to meters. So we started off with 104 kilometers. We moved that decimal place 1, 2, 3 jumps to the right. So we basically just filled in 3 zeros after 104, which gave us 104,000 meters. So 104 kilometers is 104,000 meters. 104,000 meters.
Another question, sir. Do we put that decimal at the end, and does it do anything if like do we have to put that decimal at the end?
Nope, you don't have to. Like, are you talking about if you want to put the decimal like right here?
Yeah.
And no, you can leave it off if you want. If it helps you to keep track of it, then yeah, feel free to put it at the end. But if you just leave it off and don't put it in there, that's totally fine. I know that if we don't have any like decimal points back here, then I know that's where it would be, even if you don't write it in. Good question. Any other questions about doing these conversions, going from one size measurement to a different one? All right, I'm going to do one more with you guys here, just so that we can kind of see like the full extent of our examples. All right. Let's say that we have 7 milliliters. And I want to know how many liters is that. So we have 7 milliliters, and we're going to turn it into liters. So first step, figure out our starting and ending positions. Milliliter is our smallest unit. It's down here at the bottom of our ladder. So that's our start. Liter is one of our base units. So it's hanging out here at the base as our ending point. So we're starting at milliliter. We're going to liter. So first off, how many steps on our ladder do we have to take in order to go from milliliter to liter? So if we're starting here at milliliter and we're going not there, but here for a liter, how many steps do we need to take from milliliter to liter? 3. Yes, Annette. Sorry, I just saw that. Good. Annette is correct. It's going to be 3 steps. 1, 2, 3 to go from milliliter to liter. From down here back to our base. 1, 2, 3 steps. So are these 3 steps to the right or 3 steps to the left?
To the left.
To the left, exactly. We went from down here to over here, so that's going to the left. So we started out with 7 milliliters. So our decimal is over here at the end of the 7. And then we got to go 3 jumps to the left. So we're going to go 1, which puts us in front of 7. Then we have to go 2, 3 more. So now our decimal point is over here. So again, these empty spaces right here, we're going to fill in with zeros. So if we have 7 milliliters, what is that measurement in liters? So if our decimal point is over here now, and we're going to fill in these blank spaces with zeros, then what is our new liter measurement? Anna, it is not 0.7, although it's close. Annette, you're also close, but you have your decimal point in the wrong spot. Hey, Annette, you did it. Congratulations. So if everybody wants to check the chat, Annette has put down the right answer. It is 0.007 liters. So our decimal point started over here initially, and then we moved it actually, hold on, here we go. So our decimal point was over here initially, but then we moved it 1, 2, 3 jumps to the left because we did 1, 2, 3 jumps to the left. So we started off with 7 milliliters, and then we did 1 jump in front of the 7, and then 2 more jumps. So we put zeros here. And so we ended up with 0.007 liters is equal to 7 milliliters. So we figured out our starting and ending positions. We figured out the number of jumps to go from those positions. And we figured out the direction that they're going to go. They're going to go to the left. And then we did that with the decimal point in our number. All right, so that is sort of the basic steps that you guys are going to go through when you get to this point in the homework. I think it's the homework tomorrow that does a lot of this conversion stuff that we were just talking about. All right. Does anybody have any more questions about converting between the different sizes of metric units? All right, so by the silence, I'm going to guess that everybody feels pretty okay with this, at least so far. So for the daily assignments for today and tomorrow, they all deal with these metric units and what they represent and how to convert between them. So if we look at the assignment for today, it's basically kind of a review of some of the stuff we talked about at the beginning of the class. So first, it's asking about, for these units, these kind of abbreviations of these units, is this a type of length? Is it a type of mass? Is it a type of volume? Or one that they add in here that we didn't really talk about is time. But luckily, time works the exact same way on the metric system as on the conventional American system, where we still have seconds, minutes, and hours, and all that good stuff. Like so, for example, right here, this S represents seconds, number of seconds. So that's kind of the first part of the homework. The second part says, okay, now if I write out each one of these measurements, whether that be milliliter or kilometer or centimeter, what is the correct symbol? So is it G? Is it km? Is it ml? Which symbol represents this particular measurement? And then the third part down here just asks you to kind of fill in the blank with the most appropriate unit. So do these different situations refer to liters or kilograms or millimeters or liters? What unit would fit most appropriately in whatever is being described in these sentences? So it is a lot of questions, but it's a lot of really quick, short answers. So hopefully you guys are able to get through that pretty quickly. And then the assignment for tomorrow is all about doing those conversions that we were just looking at. So it gives you a starting unit and it asks you to convert it into a particular unit, whether you're going from milligrams to grams or meters to kilometers or liters to milliliters. You're doing these exact same steps for conversion that we were just looking at. Determine your starting and ending spots. Take the steps on the ladder to go from the beginning to the end, and then do those exact same steps with the decimal point in your number. To help make that one a little bit easier, On the notes for today, oops, that's not it. On the notes for today, besides the actual notes that we looked at, I also included a slide of just the ladder. So if you want to have this kind of pulled up in the background so you can look back and forth at it while you're working on the Wednesday homework, you can go in and look at this to kind of help you remember, okay, how many steps is it between kilo or basic, or between milli and centi, or whatever type of conversion it is that you're doing. All right. Does anybody have any final questions about anything that we talked about here so far this evening? Any last thing that you're still a little bit confused about or that you want me to go back over?
No, sir.
Nope, no question.
All right, thanks, Breeze and Veronica. So as always, if you do have questions about anything or you get stuck with one of those problems, feel free to reach out to me. You can shoot me an email, you can shoot me a text, you can leave me a comment on the Google Classroom, and I'll do my best to get back to you as soon as possible. I do want to mention